Okay, so I thought I could make a short video on describing the idea of what an equivalence is because it comes up in your titration curves, and I think understanding this idea will help you understand buffers a little bit better and also drawing your titration curves. So in its most simplest form, we say that an equivalence, all we're saying that an equivalence is, it just sounds like its name, is it's an equal amount. So for example, if I had a person, okay, here's one person, an equivalence amount to this would be, for example, if we're talking about shoes, would be one shoe. It's just an equivalent amount, or it could be one glove if we're drawing a glove. Okay, one glove. Okay, so we always talk about equivalence. All it means is it's an equal amount. Now, the idea behind it is that we have a reference value with which we refer to. So it could be an amino acid, it could be a person, it could be anything that we're trying to see how many more of the other thing we need to make it an equal amount, to make it the same amount so that they cancel out. So I know I said that in a confusing way, but what I'm trying to say is that if let's say our reference value is one person. So that means that one equivalence would mean that we're using the same amount, one person, one shoe. So now if I wanted to fully put on the normal amount of shoes that a person wears, how many shoes do you think the person would wear? Well, people wear two shoes. So you need two times the amount of this because each person can wear two shoes, right? So you would say that you need two equivalents if our reference value is a person, of course. So now let's say that, for example, we had two people. So how many equivalents would you need to fully put on the shoes that two people need? Well, you would need four shoes, okay? And this idea continues going on. So if you had three people, you would need six shoes. So each person needs two shoes, and that is the basic idea of how the amino acids work as well. So for example, if I drew your amino acid, let's say we're drawing our amino acid over here. Okay, so so we talk about amino acids, and what we're doing to the amino acid on our titration curve is we're adding equivalents of NaOH, or we're adding just molecules of NaOH to deprotonate our amino acid, or to fully deprotonate our amino acid. So, well, let's think about it. Well, if we had one amino acid, what do you think one equivalent would be? Well, if it's one amino acid, it would just be one NaOH. Okay. Or it could be, instead of one amino acid, if it was 1 mole of amino acid, then it would be 1 mole of NaOH. If it was 0.05 moles of amino acid, it would be 0.05 moles of NaOH. An equivalent, again, all it means is an equal amount. So now if we're saying that we had one amino acid and an equivalent is one NaOH, well, think about it like this. How many different ionizable groups does your amino acid have? Well, if we're looking at our amino acid, we have the alpha carboxyl group, we have the alpha amino group, and we have the thiol group here. So we have actually three groups that can get deprotonated. So the idea behind this is, well, if we need three groups that we need to deprotonate, well, we would need three NaOHs, i.e. three equivalents, to fully deprotonate this amino acid. And that's exactly what we do when we do our titration curve. So if I drew the titration curve for the amino acid cysteine, you would see that you would actually need three equivalents to fully deprotonate it. And the idea here is that for any problem that you have, however many ionizable groups you have on your amino acid or your short peptide, that's how many equivalents you would need, because that's how many molecules of NaOH you would need to deprotonate it. And just so that you guys have a formula to go to in case you are ever lost, the formula that we use to calculate our equivalence, because remember, we always said that it's in reference to a reference value. We say that it is the moles, because in general we do moles, but it could be molecules, it could be anything else, but it's the moles of, let's say, for example, NaOH or HCl. It's the thing that's protonating or deprotonating our amino acid, and then that's over the moles of the amino acid we are using. Okay, so in this example over here, let's say we had 1 mole of amino acid and we had we're adding NaOH, okay? So in this case, and let's say that we add 3 moles of NaOH, so equivalence equals 1 mole of amino acids, so 1 mole of, or 3 moles of NaOH over 1 mole of the amino acid, which was cysteine. So that means that we added 3 equivalents, and again, that's the whole point, is that we wanted to fully depronate our cysteine molecule.